All right, everybody, this is a podcast for day 3. It's a trig identity. If you see a unit circle on the right side here, and the hypotenuse is 1, and we know the opposite side of the triangle must be sine theta, and the adjacent side has to be cosine theta. Because sine is opposite over hypotenuse, and this side over 1 is sine x, so this has to be sine theta. And then because I know tangent of theta is opposite of adjacent, opposite is sine x or sine theta over cosine theta. So that's an important identity. And the Pythagorean identity is using this right triangle you see here. We can write sine squared theta plus cosine theta squared is equal to 1 squared, which is just 1. So we're going to use these two all day. Alright, simplify the following trigonometric expression. So we have cosine x plus tangent x cosine x. So every time you see a tangent, I'm going to change that to sine over cosine. So that expression is equivalent to cosine x plus sine x over cosine x times there's a cosine x over here. What you notice is the cosine x on top and the bottom will simplify because the cosine over cosine is 1, so all you have left is cosine x plus sine x, and you cannot simplify anymore. Alright, 1b, 5 cosine square x plus 5 sine square x. I notice there's 5's in both terms, so I'm going to factor out the 5, and I see cosine square x plus sine square x. And I know from our Pythagorean identity this is equal to 1, so I have 5 times 1, which is equal to 5. Alright, part C, 1 minus sine square x over cosine square. The numerator here, 1 minus sine square, because sine square x plus cosine square x is equal to 1, 1 minus sine x, if you subtract sine square from both sides, you get cosine square x is equal to 1 minus sine square x. So I can substitute that numerator, cosine square x, for the numerator. And I get cosine square x over cosine square x, and that's just equal to 1. Alright, next. Here it looks really complicated, but the first thing I notice is the tangent squared over here. So I'm going to change that to sine over cosine, but there's a squared. So first I write cosine squared over sine squared. Here's a sine squared times, instead of tangent squared, I'm going to write sine square x over cosine square x minus sine square x. Okay, maybe you see it, maybe you don't, but cosine square in the numerator, cosine square in the denominator, they simplify, and then sine square and sine square simplify. So all you have in this entire left side, the first term, is 1, and then you get sine square x from the leftover, right? And what did we just talk about? 1 minus sine square x is equal to cosine square x. So that's it. Okay, number 3, I conveniently skipped number 2. If you on number 2, if you distribute the both squares or binomials, and you will see that they're going to cancel out, and you're going to use some type of sine square plus cosine square equal to 1, and you can simplify that to 13. Number 3 is cosine x tan x over sine x is equal to 1. Now when you prove these identities, always work with the more complicated side and simplify it to make it to the other side. So obviously I'm going to work with the left side here. So cosine x tan x over sine x, well, that's equal to Now this step is not really necessary, but I just wanted to show you where I was going. Okay, here instead of tangent x, I'm going to write sine over cosine. And I get 1 because cosines cancel out and sine cancel out. Okay. Number 4. Okay, which side is more complicated? I think the right side is. So I'm only going to work on the right side and make sure I get cosine x at the end. So 1 over cosine x minus sine x. I see tangent, so I'm going to change to sine x over cosine x. Okay, so I can't do anything with 1 over cosine x at the moment, but I can change the right side into sine square x over cosine x. Then I'll get 1 minus sine square x over cosine x. And we know that numerator is equal to cosine square x using the Pythagorean identity, or some variation of that. And there are 2 cosines multiplied together in the numerator and 1 cosine x. So if you simplify one of them, I'll just write it this way. Cosine square x is cosine x times cosine x, right? Over cosine x. One of these will cancel out, and you have cosine x left, which is exactly what we wanted to show. Number 5. Alright, so you have the left and right side. Still, I think the left side is more complicated, so I'm going to go with this side. I see the 1 minus cosine on the bottom and in the denominator, and the 1 plus cosine. This is where I want to go. So it's going to be something. I have to change the sign in terms of cosine. So sine square x is going to be 1 minus cosine square x. Okay. And what I notice is that 1 is a square, like 1 square is 1, and the cosine square is cosine squared. So this is going to be difference of 2 squares, 1 plus cosine x and 1 minus cosine x, all over 1 minus cosine x. And the bracket's not entirely necessary, but just want to show that becomes 1 plus cosine x, which is what we wanted to show. Alright, number 6. Once you get these going, you just have to identify which side is more complicated. And I think again the left side here is more complicated, and I'm going to work with the left side and make it look like the right side. Alright, so what I see here is 1 over 1 minus sine x minus 1 over 1 plus sine x. And I notice on the on my goal, what I want to make in the denominator, there's no sine, it's all cosine. So how am I going to change this denominator, or these both denominators, into cosine? Well, here on the left term, I'm going to multiply by 1 plus sine x on both top and bottom, because that's 1. On the right side, I'm going to do 1 minus sine x over 1 minus sine x. Now the question is, can you do that? Can you just multiply whatever you want? Well, as long as it's 1, as long as you're multiplying by 1, that's okay. Because 1 minus sine x over 1 minus sine x is 1. 1 plus sine x over 1 plus sine x is 1. So we can do that. Alright, then I get 1 plus sine x over 1 plus sine x times 1 minus sine x should be 1 minus sine square x. Okay, minus here 1 minus sine x over 1 minus sine squared x. Okay, now that my denominators are the same, I can combine them. So 1 plus sine x minus 1 minus sine x. So that's my numerator, and my denominator is 1 minus sine square x. Okay, so from there, I'm going to change my color back to blue, and I notice that on top this negative 1 is going to distribute, so 1 plus sine x minus 1 plus sine x, so I get 2 sine x over, that's cosine squared. Okay, so I have 2 times sine x over cosine x times cosine x, right? That's cosine squared. So one of those cosine will pair up with sine and become tangent. So 2 tan x over cosine x, and that is what we want to show. Alright, here we go, another tangent example. So if you see tangent, I'm going to change it to sine over cosine. So tangent x is sine over cosine plus 1 over tangent is going to be cosine over tangent, sine, cosine over sine. You can think of it as 1 over sine over cosine, but at the end it's going to be the cosine over sine. Okay, and I'm working with the left side here. Okay, then to make the denominator equal to each other so I can add them, I'm going to have to multiply this by 1 and this one by 1. But instead of just 1, I'm going to do a clever form of 1. So here I'm going to do sine x over sine x. On this one, I'm going to do cosine x over cosine x. That way my denominator is going to be sine x over cosine, sine cosine. So here on the left side, I have sine squared over sine x cosine x plus cosine squared over sine x cosine x, which is sine square x plus cosine x. Do you already see where I'm going with this? And sine x, not plus, just cosine x. And that's equal to 1 over sine x cosine x, which is what we wanted to show from the beginning. Alright, last question. Hopefully the video is not too long. We'll see. Alright, I'm going to factor out, it really doesn't matter which side you work with, so I'm just going to work with the left side. I'm going to factor out sine squared, and I get 1 minus sine squared x. Okay. Then, change my sine squared x to 1 minus cosine squared, and change my 1 minus sine squared x to cosine squared, and then distribute the cosine squared.